Hello and welcome to yet another video of Cornerstones of Math. Today we are going to compare some numbers. The first problem is, when a and b are both positive, compare a to the power of 2/3 plus b to the power of 2/3 and a plus b to the power of 2/3. In the second problem is, when a is greater than b and both are positive, compare a to the power of 2/3 minus b to the power of 2/3 and a minus b to the power of 2/3. So let's solve this, and I will use substitution for simpler expressions. Let a to the power of 1/3 as x and b to the power of 1/3 as y. Then a equals x cubed and b equals y cubed. This substitution is not really necessary because you can actually solve the problem without this process if you are good at handling exponents. But I will use substitution so that I don't have to deal with fractional exponents. So the first one, let a to the power of 2/3 plus b to the power of 2/3 as p and a plus b to the power of 2/3 as q. Then in terms of x and y, p equals x squared plus y squared and q equals x cubed plus y cubed to the power of 2/3. And x and y are positive. In order to compare two numbers, we need to calculate p minus q and check whether it is positive, 0 or negative. But determining that is still not easy due to the still existing fractional power 2/3 here. So instead, we calculate p cubed minus q cubed because that will eliminate the fractional powers entirely. Specifically, it gives x squared plus y squared cubed minus, and q cubed is x cubed plus y cubed squared. So we don't have fractional powers anymore. And if we expand them, we have first x to the power of 6 plus 3x to the power of 4y squared plus 3x squared y to the power of 4 plus y to the power of 6. And for the second part, we have x to the power of 6 plus 2x cubed y cubed plus y to the power of 6. So notice that x to the power of 6 and y to the power of 6 got cancelled out. So we only have this term, 3x to the power of 4y squared, and this term, minus 2x cubed y cubed, and this term, 3x squared y to the power of 4. Notice that we can extract x squared y squared as a common factor. Then we have 3x squared minus 2xy plus 3y squared. Here, let's write it as x squared minus 2xy plus y squared first, then 2x squared and 2y squared. So this 3x squared is split into x squared and 2x squared, and 3y squared is split into y squared and 2y squared. Then this part is a perfect square, which is x minus y squared. Then we have twice the x squared plus y squared. Because x and y are both positive, x minus y squared is non-negative and x squared plus y squared is positive, making the entire thing positive. This means that p cubed is greater than q cubed, which means p is greater than q, meaning that a to the power of 2/3 plus b to the power of 2/3 is greater than a plus b to the power of 2/3. So this is the answer to the first problem. For the second problem, the basic settings are the same. We use the same substitution. Also, let a to the power of 2/3 minus b to the power of 2/3 as r, and a minus b to the power of 2/3 as s. Then, in terms of x and y, r equals x squared minus y squared, and s equals x cubed minus y cubed to the power of 2/3. Here we compare r cubed and s cubed, so we calculate r cubed minus s cubed, which equals x squared minus y squared cubed minus x cubed minus y cubed squared. And here's the part that is different from the previous problem. Here, both x squared minus y squared and x cubed minus y cubed are factorable, and if we factor them, we will have some common factors. Specifically, x squared minus y squared is factored into x minus y times x plus y. So we have x minus y cubed times x plus y cubed. And x cubed minus y cubed is factored into x minus y times x squared plus xy plus y squared. So we have minus x minus y squared times x squared plus xy plus y squared squared. So notice that now we have x minus y squared as the common factor. Then we have first additional x minus y, then x plus y cubed, and minus x squared plus xy plus y squared squared. So we still have some pretty involved expressions right here, and there's not a magical trick that I can show you to get around these lengthy calculations. So let's just keep calm and expand to see what happens. The expansion of x plus y cubed is x cubed plus 3x squared y plus 3xy squared plus y cubed. And for the expansion of x squared plus xy plus y squared squared, we use this formula to obtain x to the power of 4 plus x squared y squared plus y to the power of 4 plus 2x cubed y plus 2xy cubed plus 2x squared y squared. And then we have to expand this part, which will give 8 terms. Again, remaining calm. First, we carry out these multiplications, which gives x to the power of 4 plus 3x cubed y plus 3x squared y squared plus xy cubed. Then we carry out these multiplications, which gives minus x cubed y minus 3x squared y squared minus 3xy cubed minus y to the power of 4. And for this part, notice that x squared y squared plus 2x squared y squared gives 3x squared y squared. So at least we can combine these two terms, which gives minus x to the power of 4, then combined term 3x squared y squared, and remaining terms minus y to the power of 4 minus 2x cubed y minus 2xy cubed. Now here's the important observation. Due to the nature of the terms that we have expanded and the way we did the expansion, all of the terms in this parenthesis are 4th degree terms. That is, it only consists of these 5 terms: x to the power of 4, x cubed y, x squared y squared, xy cubed, and y to the power of 4. So we can easily group terms of the same degree and simplify. First, for x to the 4th power terms, we have plus x to the power of 4 and minus x to the power of 4, so they got cancelled out, and there are no x to the power of 4 terms. For x cubed y terms, we have plus 3x cubed y, minus x cubed y, and minus 2x cubed y, meaning that they also got cancelled out, and there are no x cubed y term. Next, for x squared y squared terms, we have plus 3x squared y squared, minus 3x squared y squared, and minus 3x squared y squared. So in total, we have minus 3x squared y squared. For xy cubed terms, we have plus xy cubed, minus 3xy cubed, minus 2xy cubed, so we have minus 4xy cubed. And finally, for the y to the 4th power, we have minus y to the power of 4 and minus y to the power of 4, so we have minus 2y to the power of 4. Here, notice that we can extract minus y squared, so we have minus y squared x minus y squared times 3x squared plus 4xy plus 2y squared. Here, y squared is positive and x minus y squared is positive because x is greater than y because a is greater than b. And 3x squared plus 4xy plus 2y squared is also positive, so the entire thing is negative. Therefore, r cubed is less than s cubed, So r is less than s, meaning that a to the power of 2/3 minus b to the power of 2/3 is less than a minus b to the power of 2/3. And that's all for today's video. Thank you for watching, and I will see you in another video.